We talked about the technical aspects of the triggered and the synchronous scopes and how they work under the hood and what their function is. But there's a couple other components relating to both of these that have to do more with interpreting the data if you were on test or during replay. So what I have is a simulator with a 60 hertz signal, and I have a tack signal also at 60 hertz. So the first thing you can observe is that the signals, even though they're on, they're stationary. And so if I were to tick up in frequency just 1 hertz above, or 1 or 2 hertz above 60 hertz, all of a sudden the data is now sliding across the plots, and these are only with the synchronous and the triggered plot, the triggered scope. So what this is showing is that the vibration, or whatever the signal is asynchronous with the rotating machinery, or it's sometimes called a traveling wave. And if we lock it back into a multiple of the engine speed, we can see that now we're at 120 hertz, and the signal is now back, is synchronized with the rotation of the machinery. With this, so both of these plots are showing this. So anytime the signal seems to be traveling by as this plot's going, it's asynchronous, and then if it is locked in and not moving, then it is synchronous with the engine rotational speed. Only with the synchronous scope plot, the other item you can determine is how many engine orders the frequency is related to. So what we can do is we can see if I change this signal back down to 60 hertz, this would be equivalent to engine order of 1. So each cycle is basically of the engine, rotation of the engine is producing a sinusoidal vibration like this. It's basically the same frequency as rotation of the engine. If for whatever reason the frequency is higher than that, then in this case, for example, it's 120 hertz. See, there's 2 cycles, so this would be considered a 2EO vibration. And so that just repeats to each of these engine orders, 3 or at 180, and so on up the line. So it's kind of a unique thing you can do with the synchronous scope plot. Is you can see if you have a tone that's in your signal that you can make out, that you kind of assess how many engine orders this is in relation to the engine speed, and that would be in the case of it is a synchronous vibration, obviously. So just 2 additional things you can observe in the triggered scope and the synchronous scope that are related to analyzing the data rather than the technical aspects of these plots.